All right, testing, testing. Welcome to CS, always. I think it's that portion of the board and not the markers. CS4510. The topic of today is something called syntactic structures. And this is lecture, what is this? L05A, thank you. Yes. So what is syntactic structures? Syntactic structures is this monograph by Noam Chomsky. We're going to talk about Noam Chomsky's work today. It's a foundational document in the theory of linguistics, which we'll also define and talk about today. But it's incredibly short. In fact, he came up with this book as a set of lecture notes for a course he was teaching, because he had a different book that was 1,000 pages. And this is like the better version. Now, we're not going to talk about syntactic structures in the context of it being like good or anything, because there is some like things that have not aged as well and so on, but we're going to talk about it in the context of it being the first document of its kind. The moral of syntactic structures is that Noam Chomsky brought a very scientific worldview into what was a very unscientific and kind of empirical based field. Linguistics is the study of language. It's the study of the history of the language. It's the study of the composition of sentences, the structure, the meaning of sentences, everything, right? Why do words sound like that? You know, that's sort of everything around that question is the study of linguistics. And many people, up to this point, linguistics was a very field-heavy work in the sense you wore a canvas shirt and you hung out in the jungle and then you recorded utterances by people and just trying to say, okay, this is the kind of language they speak, this is how they form sentences. Now Chomsky goes, that's an empirical view, which is not like incorrect or anything, but Chomsky brings in, basically the moral is he brings more math into someone else's house. And he goes the other way. He comes up with proposals for the way like a theory may work, and then he talks about how these can explain certain things. And that's sort of the whole moral of today. And to kind of explain to you why this is such an important foundational work, I mean, it's really started the study of linguistics more as a science than something else. So it's about the science rather than the actual content. And it's going to take the whole 2 lectures for us to explain like why it's important in some sense. Before we get into that, we can talk about what linguistics is. So we're just going to kind of go through all the chapters. So what is language, first of all? Like, this is a complicated question, and basically the point of today is like, why is this question? I mean, we're working in the context of this question being complicated. So we're kind of doing language right now in the sense that I'm speaking and you're listening, but you have 2 people, let's say, and between them they communicate, and let's say this guy says horse, right? Now, I am using my vocal cords and expelling air through them to make this utterance, horse, horse. Now, I communicate this to you and you picture a horse, probably, right? Hopefully. Paying attention and all that, right? Okay, that's a horse. But observe kind of when the first problem is that in the context that we're working in, that in an information theory sense, communication, language is a lossy channel. So the idea, the concept, everything surrounding the notion of horse is vastly more complicated than the syllable used to describe the object, horse, which is, in some sense, every one of you should be picturing a different horse, right? So the first important part about language is that it's, to some, and not to everyone, but to some people, it's not a study of the structure of words and the way that we speak, and in a very measured sense, like what language is, but rather it's a study of ideas, because the ideas are like in the brain somewhere, they're in some data structure, there's signals on wires, and we don't know how we have no idea how to extract the ideas from the mind, except through the use of language. So the first kind of thesis, which again, as we'll discuss today, not everything here is widely accepted, but we'll just kind of discuss the framing of it, is that the study of language is the study of ideas, and in contrapositive, limitations of language limit ideas themselves, right? There are concepts that we perhaps cannot explain, but we understand. Are there? Who knows? The only things that we can understand maybe are those things that which we can communicate and explain. So first off, that's kind of one important theory of linguistics, and sometimes why certain linguistics, people in linguistics camps consider them more like theorists of the mind in some sense, Chomsky included. But again, not everyone agrees with this. Some people are just really like nerding out about what a gerund is and things like this, you know. So that's the first thing about language. The second thing about language is that it's really important to us as not just a civilization or a culture, but like as a species, because all animals appear to have some kind of communication. But the ideas that they communicate are vastly less complicated than the ones that we can communicate, you know? How do you tell a baby not to touch the fire? You say, you know, don't touch the fire, somehow it understands that, right? Don't do the dangerous thing. So the babe, now let's say we were a species that did not communicate, okay? Here's what would happen. We would have some number of babies, a certain percentage of them would touch the fire and they would die. And the babies that did not die would live on with an ingrained genetic component of an innate fear of fire without knowing about why that happened. So the only way for other species that lack large amounts of communication to pass down knowledge in some sense is through evolutionary culling. And that is really slow and really bad. Now the fact that we have language means that I can tell a baby, don't touch the fire, and hopefully the baby will not touch the fire. And then it doesn't have to get culled, right? We can learn things from our ancestors without having to have our brothers and sisters perish before, you know, that knowledge gets communicated, right? We're the only species that appears to have as complex of a communication pattern. Now this is a subjective thing. Do other animals have the ability of communication? I mean, dogs bark, they whimper and so on. They have a kind of limited, very simple ideas, right? You could probably say maybe dogs can express at most up to 7 concepts. You know, I just made that number up, but you probably believe that, right? Humans, today we understand all kinds of even the words I'm saying now. Somehow these are words you've never heard before in this order, but you can understand the idea from the words even though you've never heard this sentence in your life, you know. Every day you interact with new sentences, somehow you can extract meaning from those. Kind of an interesting thing. So language, very interesting for these 2 reasons, right? Questions so far? Yes? Oh, no, okay. Any questions so far? Okay, the first framing is like, what is the point of linguistics? What should we do from, like, as a study, if we want to embark upon, I mean, there's a lot of things for us to point at. What should we look at first? And this is the sort of the core idea here. A scientific theory, and I'm using the word scientific loosely here, theory of language should help distinguish the grammatical from the ungrammatical. So there's a lot you can ask here, but we'll basically frame ourselves on this first initial question. We want to tell apart utterances, by the way, language, both written and spoken. Some languages are only spoken and not written, and some languages are only written and not spoken. And especially in the fact that we all speak English with a lowercase e, we're going to just basically use the language of study as English. But know that most things that we're going to talk about are going to apply to most languages. Distinguishing the grammatical from ungrammatical is basically a small thing. Somehow, you know when word mean less. I speak and you know not good, right? But if I speak good, you know it's grammatical, right? So everyone is working with an internal grammatical and ungrammatical brain engine, a subcomponent of the brain that when I speak, you know that's a grammatically correct sentence, or that's an ungrammatically correct sentence. if I give you an utterance or perhaps even a string of words, you can tell me you can always tell me with 99% confidence that's grammatically correct or that's ungrammatical, right? Can you do it 100% of the time? This is a very difficult question. And to explain why this is a difficult question, I'll tell you a totally unrelated story. Are you familiar with the parable of Diogenes and Plato? You guys heard this story? Okay, so both these characters, let's see, Plato was an established thinker. He had a school in Athens. He was responsible for the theory of forms. Diogenes was homeless. He lived in a barrel. He was a serial public masturbator. Plato was obsessed with this concept of a hierarchy of all ideas in the sense of, it was called the theory of forms. So he was obsessed with all possible concepts, real or ideal, and an organization of these concepts, and today what we would call a directed acyclic graph. So from the form of beauty, you may derive objects that are beautiful, and then you may derive imitations of beauty and so on, something like this. So like the concept of beauty is purer than objects that are beautiful, something like this. So he comes up with this definition of man, as in the context of humanity. And he says, that which is a man is a featherless biped. So what he asserts basically is that man is equivalent to this concept of featherless biped. Right? Importance of this definition. First off, man is in the concept of humanity, is an intuitive definition. This is something that, like the concept of grammatical and ungrammatical, lies within ourselves as in the domain of the intuitive. Featherless biped is something that lies in the domain of formal. This perhaps is disagreeable. This is not. So this is a more formal notion than this one, right? And if we were to do a flow chart, we could say, does it have feathers? If the answer is yes or no, and if it does not have feathers, is it a biped? And if it says yes, I'll put yes here. If it's a featherless biped, then it's a man. If it's not a featherless biped, and then it's not, right? So that's kind of the flow chart, I guess we would say, that Plato comes up with. Now this kind of works, is this a good definition? This works for most of the objects Plato would have seen. Imagine an ancient Greek man. What do you got? Toga, rock, mountain, cloud, goat, sheep. That's basically it, So it kind of works for most things. Now Diogenes, of course, comes in, he crashes the scene, and he holds up a plucked chicken, and he famously says, "Behold, a man." So is a plucked chicken featherless? Okay. Is it a biped? Yes. Is it a man? So we have a counterexample here between a man and a featherless biped. We would all agree that a plucked chicken is true on the right and false on the left. So therefore, this is not a good definition. Now, could you modify this definition and maybe try another set of checks? You could say, what about the next definition Plato gave was a featherless biped with fingernails. Okay, but could you come up with a similar counterexample to a featherless biped? Give me a counterexample, that which is not a man, yet is featherless, a biped, and has fingernails.
I don't know about exactly that, but I could give you a man who has feathers and is not a biped.
Okay, interesting. Tell me that.
Well, in the same sense of plucking the chicken, if you were to, glue a bunch of feathers to a man and make him only walk on 4 limbs, then he's...
I'll accept that. Yeah. If I were to get really fine grained in the context of man being humanity as like what makes us human, some may consider if you take a man with feathers and he walks on 4 legs, that man is in fact subhuman. So I would say 90% of the people would agree. Can you give me one that's 99%? short answer, just take fingernails and glue them on a plucked chicken, right? So that's going to be feathers by fingernails. Anyway, what is a good definition of man? Again, in humanity. To Plato, that which is man is what Plato says is a man. That's about as good of a definition as you could ever hope for. Here's Plato. Inside him somewhere is the definition of man, and any sort of definition attempts to extract this from him to not make it part of the intuitive, but make it part of the formal. And in any scenario that this occurs, is going to fail in some sense. There are many concepts that are intuitive and stay in the domain of intuition and can never be formalized. Logical thinking is not one of those, by the way. But the concept of what is or isn't a member of humanity is one. If you attempted any such checks like this, it would always fail, I claim. It would never be perfect. And there are many other things that satisfy this. The moral of the story here is that grammatical and ungrammatical is such a concept. You could never extract the definition of what makes a sentence grammatical or what makes a sentence ungrammatical with perfection from someone because, first of all, people have disagreements. So any such definition must be undisagreeable. But yet, from person to person, I claim we could probably find a sentence that maybe we disagree or agree on is grammatical or ungrammatical, right? Yet, you are still the distinguisher because you can determine if something is grammatical or ungrammatical, right? So, first off, we're working with an intuitive concept. We can never make it too formal. So any statement that we say is going to be conditioned upon the fact that there's a bunch of conditions there, which is like, it's in the intuitive sense, we have to be very precise, but we can never be as precise as mathematics in some sense, right? So that's the first limitation. Here's another concept that's in the domain of intuition. What a stop sign is. Do we all know what a stop sign looks like? How do you know what that's a stop sign? If I showed you a stop sign, you could tell me that is or isn't a stop sign, right? Explain to me though. Explain it. Explain why you know it's a stop sign or it's not a stop sign.
Red, it has 8 sides and it says stop one.
Okay, what if it's at a slight angle? Is that now an octagon?
It's not. Oh, well, I can see it in my head and I can turn it.
Yes, yes. But can you explain that to someone? What if there's a shadow covering a portion of it? Okay. The moral is that that's what CAPTCHA does, okay? And this is basically all machine learning does. Imagine you did this to 10,000 if statements. That's what machine learning is, okay? Now, it explains something that is hard to do, the hot dog, not hot dog, same thing, right? The reason you repeatedly have to solve CAPTCHAs is that you provided information about is this a stop sign or not, and it somehow can extract from that. Now, of course, in a similar sense, no such thing will perfectly explain when a picture contains a stop sign or not. But that's okay. What if it's right 99.99% of the time? So machine learning works enough. We're fine. What a stop sign is also a concept that cannot be explained yet. You can recognize it pretty easily. If there's a shadow covering it and so on, it would disprove any such check. If it's a perfect octagon, you say, what about an angle? If it's bright red, what if there's a shadow covering part of it? So part of it's dark red, part of it's bright red. You say, okay, well, it's bright red, but then there's a shape of a shadow covering part of it. You say, okay, what if it's rusty? You know what I'm saying? So no such flowchart is ever going to be perfect. Same thing with grammatical and ungrammatical. That's the moral. Make sure I'm back on track, right? Okay, questions? Okay, let's go on to chapter 2. By the way, chapter 1 was only a page long. So I highly recommend you read syntactic structures. I'll just show it to you real quick, how short. So that's the preface, table of contents, introduction, that's it. So all this extra stuff was not there, but that's how short the chapters are. So I highly recommend you read through it. There's only 10 such chapters. So the next part is the difference between syntax and semantics. Right? Syntax is about representation. And semantics is about meaning. So I think the Aristotelian definition of or maybe it was Archimedes, but the Aristotelian definition of language is sound with meaning, which is a bit too vague to argue with, but every sentence has two portions. It has syntax, is as the sentence as it is itself represented, and it has meaning. So the structure would be part of its syntax, whether or not the sentence is passive or active, for example. That is a syntactic property of a sentence. Whether or not a sentence is interrogative. I can't spell that, but interrogative. Is the sentence interrogative? Is it declarative? Those are also syntactic properties. Semantic properties could be, for example, is it true? Is the sentence factually correct? That would be like a very strongly semantic property, right? Let's see. In the context of this course, there is also, we will deal intimately with syntax and semantics, right? Syntax is the representation of an idea, and semantic is the idea itself. So, in the context of, let's say, DFAs, syntax would be the automaton. And then semantics would be the language which is decided by the automaton, right? So the automaton is a description of the language, but the language itself contains vastly more understanding and things than the DFA does, right? The DFA is a description of the language, it's the syntax, but then it's an explanation for the idea, but the idea is the language. So that's more of a context in automata theory. But back in linguistics, you have a representation of a sentence, but then the sentence may convey an idea, and the idea is the semantic value of the sentence, right? So the reason I'm mentioning this is one of the first things that Chomsky does is this kind of extremal sentence. Consider the sentence: colorless, green, ideas, sleep furiously. Okay. Is that a sentence? Okay, yeah, it's a sequence of words. Is it grammatically correct? Why?
Follows the format and structure of a sentence.
Yeah, that's the best, in the context we're working with, that whole parable about Diogenes and Plato, that's the best you could say. You can't do any better. It's like, it sounds correct. That's the answer that I could hope for. What else could we say? The word pattern makes sense, the intonation, you know, the way the words connect and rise and fall, it sounds like it makes sense. So this is a sentence which is syntactic, right? It is syntactically, it is a grammatical sentence, okay? What is the semantic value of the sentence?
Nonsense.
Yes, it's meaningless. So this is our first example of a counterexample. And in linguistics, formal linguistics, it's full of such extremal sentences, where in the same way that a chemist may measure, like stick a thermometer in a hot beaker or something and get a data point, we just kind of speak about language and we can also collect such extremal data points, right? This is an outlier, but any scientific theory should sufficiently explain all these kinds of outliers. We have a sentence that is syntactically correct, yet meaningless. So it is syntax 100%, semantics 0%. So this is a counterexample to what was a commonly thought idea at the time, which is what I said earlier, is that the limitations of language must necessarily limit the ideas used to represent them. But it does not imply that there is an if and only if, that if every grammatical sentence must convey meaning. In fact, you can have sentences convey meaning and be ungrammatical, and then you can have sentences be grammatical and convey no meaning, right? So this is such an example of it, right? This is a famous example. Have any of you heard this example before? Okay. Questions on that? Any disagreements? By the way, we're not working in math where everything is formal and you can't disagree with me. We're working in linguistics where you may have objections and it's not fully grounded. And if you have objections, please word them, right? Anyone disagree with this explanation though? Okay. Consider the second sentence. Furiously, sleep, ideas, green, colorless. The second sentence, is it grammatical? Okay, why not?
Feels wrong.
Yeah,
Good enough.
vibes.
Yeah, it just furiously sleep ideas green colorless. Doesn't sound correct, you know. The first one has, again, the intonation that we would expect. Colorless, green ideas sleep furiously. In contrast, furiously sleep ideas green colorless. It doesn't make any sense. So, internal distinguisher, that's ungrammatical. Okay. Grammatical, ungrammatical. What's the difference between these two sentences, though? Yeah.
The order of the words.
Yeah, it's simply the reversal of the order of the words from the first sentence, right? So here's the extrapolation that we get from this. Is independent of. Grammatical in English is independent of statistical approximation to English. Suppose you took a frequency of the most common sentences and least common sentences. We would say that both of these sentences are probably assigned a negligible probability of ever being spoken, which is basically zero. I mean, the only time it's been spoken is when we're discussing the sentences itself. But if we exclude that, then basically these sentences have never been uttered. So these two sentences have the same approximation to English in the sense that they have about the same amount of being common or not being common, right? Yet, A is strongly grammatical, B is strongly ungrammatical. So what Chomsky says here is grammatical in English is fully independent of statistical approximation to English, in the sense that there is no relationship between these two concepts. Now, this you may disagree with. Does anyone disagree with this? Yes?
So, this is a question. So by statistical approximation to English, you said the odds of it actually being said?
Yes, so suppose we took every sentence that has ever been spoken by any human ever, and we assigned it a value based on how commonly it's spoken. Hi there would be a sentence that is very commonly spoken. Both of these sentences, so that would have a high value. Both of these sentences would have a very low value.
Even though one's grammatical and one's not.
Exactly. So what he says here is that you cannot use how frequent a sentence is spoken to determine if a sentence is grammatical or not. But if you think about it, it does sound plausible. If a sentence is spoken more frequently, certainly it's more grammatical. But he says here, an extremal counterexample. I want to ask again, does anyone disagree with this notion? Yes?
I disagree slightly in that languages are what people speak.
Yes.
So if no people speak it, then does it make it, English?
That's a good question. And I guess the answer goes back to, I guess in your interaction with day-to-day, you probably have only interacted, you would think at least that you've only interacted with sentences that you've heard before. But I claim the reason we come to class is that on the daily you interact with sentences you've never heard before. And you can extract meaning from them. The sentence I'm saying right now you've never heard before. If you did, you wouldn't come to class, right? So usually you interact with sentences that have very negligible probability of being spoken. Here's another, to be more applied, I think there's a stat like 30% of daily Google searches have never been searched before in the history of Google. So Google cannot just do a lookup table for every possible search. They have to do something data structure-wise non-trivial. You can't, if you search weather, you can't just return the same static page. That's a common search. But there are searches, 30% of them every day, never been searched ever in the history of Google. That's a first example. And again, colorless green ideas sleep furiously, we agree is grammatical, but never been heard. Oh, by the way, sentence A is so famous that it is actually very common now because there's like a poetry contest of how can you use this in a sentence? Can you actually use this in a way that's meaningful? So ironically, by choosing this as an example, he's made it famous, and it now is not an example that he would want, right? I guess what I wanted to ask about is like, oh, okay, yes. I forgot to mention the second portion. He goes on to conjecture the following. Not conjecture, but assert strongly. No probabilistic model can fully explain when a sentence is grammatical or ungrammatical. Would that be something you agree with or disagree with? Yes.
I would disagree with it, but only because ChatGPT exists and that's all.
Yeah, and that's a good enough example. So people today argue all the time whether or not ChatGPT is correct, but that's a semantic property. Not a single person can sufficiently argue that ChatGPT is ungrammatical. Even if you say ChatGPT talk like a cowboy, it'll do that. You know, so it's very grammatical, but it's all probabilities and weights and somewhere down there. Two things I'll say. Actually, three. First off, this is a result from 1954 or 1962 or something like this. So this was like an ancient idea before we had a strong understanding of what it meant to use probability in algorithms. So what he's really arguing against here is two things. Likely a formula. So like, let's say you took the formula, the value we talked about of approximation to English, the frequency of it being spoken, and then let's say we squared that and then we divided by the number of sentences. Something like that would be perhaps a expectation of a sentence being grammatical. He says no such formula could correctly work, and as in a literal formula of squares and square roots and stuff, because these two sentences would perhaps evaluate to the same thing, but one is grammatical and one isn't. So that's a first example. Yes?
Is it like saying that it's there's no finite formula that you can kind of write down, whereas ChatGPT kind of is a formula that's always changing because it kind of teaches.
Yeah, I guess you could say that. The second thing I'll say is, so ChatGPT, and this is a little bit of my opinion, but it is kind of cheating because we measure, so like in algorithms, we measure the performance of an algorithm assuming the code is constant and that the inputs we give it are much larger. Dijkstra's works on a graph of 1 trillion nodes, even though Dijkstra's is only a few lines of code, right? But if we have some kind of model that has 1 billion terabytes of weights, and it produces one grammatically correct output, you know, we're all impressed about that. But we should really measure these things on somehow bigger than them. Imagine you want a big O constant, and it's like, oh, it's not exponential time, it's polynomial time, just because we got the constant really, really small, right? It's one of those things that shouldn't matter, but somehow in practice it does. The other thing I'll mention is another model he's likely arguing against is something like a Markov chain, which is like a DFA. Imagine a DFA where you have weights as the probabilities. He's also saying such a computation that were to characterize English and explain English well would perhaps compute both these sentences to be the same, but we know one must be grammatical and one must not be. Something like this. So the first randomized algorithm was like, there was one earlier than this, but like well accepted was quicksort. And that was like in the 60s. So this is like 2 years before quicksort came out. And then we only really understood randomized algorithms in the 70s. And today even we don't really understand them, but we got the definitions about these randomized algorithms in the 70s, right? Rabin-Miller, primality testing, and so on. So this is prior to anything like this. He could have never predicted what a transformer is. So it's an ancient argument, and it's a good example of something that has not aged well. Actually, I'll tell you one more thing. Chomsky had a New York Times article. He's still alive, by the way. He's like 97. He had a New York Times article in 2023 about, it's called The False Promise of ChatGPT. And he argues about how ChatGPT doesn't really work. It's like it doesn't understand things. It's just the text generator, la la la, whatever. And it's, people disagree with him. And it's sort of like, it puts him in a more old school. Today, back then he was new school, and today he's old school. So 80 years, this argument has not aged well. But still, don't worry about the correctness of the argument, but the argument itself. The way we can argue about what can or cannot work based upon just like looking at some examples. I'll make the analogy again. Chemistry, you stick a thermometer into hot liquid, and then you take a number, and then you plot a graph. We're kind of doing the same thing, right? Questions on this example? Okay. So these are two examples of things that fail to explain grammatical or ungrammatical. So let's come up with one that does appear to explain something. So we've already seen this, in fact. It's just like, the next chapter is just like, it's called an elementary linguistic theory. It's basically DFAs can explain some parts of English. We'll call it a substructure. Okay, so and the example he has is the following. And then let's say we wanted to distinguish between a plural and a singular. So what we may do is we may do something like this. Wait. Okay, so this is like a DFA, and it's kind of grammatical, right? The accepted strings by this DFA are 2 grammatical sentences. We agree. The number of strings accepted by this DFA, what are the number of strings accepted by this DFA? Yeah.
2.
Yeah, just 2 of them. So, but we can in fact enumerate an infinite subset of English in the following way. Every infinite language described by a finite object must be done through some sort of recursive feature, right? Some kind of self-reference or something like this. In order to enumerate an infinite language, we need to have a loop, essentially. That's the short answer. So this produces, how many strings are accepted by this DFA now? It's more. Yes. So, but are they all grammatical? The men come, the old men come, the old men, the old men come, the old men come. Now, is that grammatically correct? Take a poll. You don't think it's grammatically correct. You think it's grammatically correct.
It's correct, yeah.
Okay. And this, again, the intuitive thing, I'm not going to re-explain that, but we see a basic disagreement. Do you think it's grammatically correct? Go with your gut and not with what a teacher told you.
I'd say it's grammatically correct.
Okay. What about you?
Grammatically correct.
Okay, so I'm sorry you're in the minority here. Now, I also agree it's grammatically correct, but it is odd, and most sentences we'll talk about today are odd. They're like, I mean, that's like kind of a weird example. So like, it sounds grammatical. It is odd because it's a hyperbolic sentence. It's impolite. It's not very nice. But it is correct, I guess. The old, if you want to put extra emphasis on how old they are. You know, these guys are old. They're old, you know. You just say old a lot. The old men come, you know. You can do that arbitrarily many times. So basically this whole section is like DFAs kind of explain parts of English. And in fact, they can enumerate an infinite substructure of English, right? So DFAs appear to be kind of useful. Here's another question. Is English an infinite language? By infinite, I mean infinite language, I mean in the formal sense where we consider subsets of strings, right? When let sigma star be whatever is appropriate, A through Z, space, comma, whatever, right? And let L be the set of strings that are grammatically correct in English. Like, for each person, you would have a different L. For example, you two would disagree on what L actually is. So you can never formalize the notion. Again, intuitive stuff. But let's suppose that we defined it in this way, right? Is this an infinite language or not?
Is sigma star the letters or the words?
The letters. So sigma is the letters. Sigma star is the words.
Created from those letters?
Yeah, so I guess words, let's forget the word word for a second because a sentence is made up of words. Let's say strings are sentences and they're composed of words, which are just also strings. So just to be too formal, right? Is this language infinite or not? The set of grammatically correct, and not just all set strings, but the grammatically correct ones. Or is this set of strings infinite or not?
If there's no token limit, I would say yes.
What do you mean by token limit?
So how many words you can string together?
Okay, so you think the infiniteness of English is dependent upon specifically how many times you can take that loop? What is this? Is it simpler to assume that language is infinite or not infinite?
Simpler.
I'd say simpler, yeah.
Infinite is simpler, right? A token limit, you would say, like, I don't know how to do, the DFA does not have a bound on some number of times you can take a loop, and doing so is difficult to compute. Let's say you can't take this more than 17 times, okay? And then every time you take it, it reduces a counter. How would you can't do that with a DFA. That's some not-DFA thing, okay? So if you assume that, and that's a pretty good point. And basically, what I want to mention is it pays to assume language is infinite. It's more useful to assume language is infinite. It's a simpler object to work with. Not only is it simpler to work with, but take the opposite view. Assume language is finite. What can we say? What are the consequences if we assume that the set of grammatically correct English sentences is finite?
Then you have DFA that is finite.
Yes. What was the homework problem I gave you?
It was,
Finite
What
language
was
or
it?
regular.
All finite languages are regular.
yeah.
Yes, exactly. So assume that there are finitely many sentences, okay? Now, here's an extension of the theory of the mind, okay? If there's finitely many sentences, then you know that every finite language is regular, okay? What was the proof of that? I think everyone may have done something slightly different, but what was the proof technique used to show that a finite language is regular? Union, yeah, of what?
Finite in sets that have one thing in them.
Yes, yes. So you just like union, like a regular expression, you just like union them together, right? What that really is, it's like a syntactic version of it as a regular expression or whatever, but it's really a lookup table. As an algorithm, you have a lookup table here. So suppose there's k sentences. We'll call it S1, SK, okay? Now, if there were finitely many sentences, your brain could work in the following. A creature could exist, where the sentences are simply hard-coded as the DFA is, and then we have assigned here in some data structure format, I have no idea how this would look, but some kind of meaning of the sentence. So you could have the sentence itself, and then you can have the meaning of the sentence encoded in the brain. And if English was finite, then this is an object that exists to perfectly characterize everything. Now again, the problem with this is you interact with sentences you've never heard before every day. The sentence I just said is one you've never heard before, yet the brain does not operate in such a way. So like theory of the mind stuff again, here's what you don't do. When I say a sentence, you don't go to your lookup table and you don't make a map from the lookup table to some sort of class of meanings, and then you extract the meaning from there, and then to respond, you choose a different sentence, which then I would extract the meaning from. That's not how it works. Somehow, the brain has the ability of analysis, which is that you take a sentence and you can extract meaning from the sentence, even though you've never heard it before. You've never heard the sentence before, yet you can extract the meaning from the sentence, right? And synthesis. Given an idea, somehow in the mind, a thought occurs and it bubbles up to the front, and then you can externalize the thought through language. And again, it's a lossy channel, it can never be perfect, but you can express what the idea is, right? Given the idea, you can express it. Synthesis, analysis. You can do these two things, and you don't really do this. Like, why would you do this? So that's another argument that it pays to assume language is infinite, because if it's finite, then this is kind of boring. I mean, this is not in accordance with our experience with language. Questions on that? Yes.
I make the counter argument that, I can't understand any sentence with 100 words.
Yes, but suppose exactly, that's a good point, actually. Suppose you can't understand, if every finite set has a longest string, right? So there's a max length if the set is finite. I claim again, though, that if you couldn't understand a sentence longer than 100 words, you could just do this. Now it would be a big lookup table, but it would work. So somehow you interact with sentences much shorter than 100 words. Every sentence I think I've said today is less than 100 words. You've never heard them before, yet you know what they mean.
Yes, but I have another counterexample, right?
Okay.
Let's say, what's your favorite movie? And can you give me a line from a favorite movie? Like, Okay. So suppose, right, so suppose that we don't have this lookup table, right? But, right, so before you watch this movie, let's say, right, then it is just an ordinary sentence, right?
Yes.
But until that line becomes famous on the internet, right, you associate it with something special. So certainly the brain is certainly lookup tableable.
I see. The difference I would say between your example and this example is that this is hard-coded from birth. Yes, but yours is an updating lookup table. But what defines the lookup table update in your scenario? I agree. I fully agree that knowledge is, and it's another counterexample why this doesn't work. In this example, every person of this species is born with this lookup table. Now, if you're talking about an updating lookup table, you would have to define how this update maybe works in the context of language, which would imply perhaps it requires analyzing sentences that have never been heard before, and we're back to the other case. Something like this, right? But that's a good example, right? So let's come back to this question. I'll do one more kind of quote-unquote proof, and then we'll talk about this some more. Because I think this is a good discussion, but I want to have it after we have the next result, okay? So we know that DFAs can explain a substructure of English, right? Good for them. Here's the next portion. English, and again, this could be any language. English is not regular. So a DFA may perhaps enumerate and explain some small part of English, but it cannot in totality explain all of English, right? Here is the classic argument. Let SI, SJ be declarative, specifically declarative, sentences, and let them be grammatical. Consider this sentence, S to be, if SI, then SJ. Okay? Let SI be S. Then we would have here, if SI, then SJ, then SJ. Let SI be S n times. What are we going to have if we apply such a recursion n times? It's going to be if SI, then SJ, then SJ, then SJ, right? How many times does this if appear? What about this then SJ part? In times?
N plus 1.
Let's just say n. Suppose that this is just n minus 1 times from the n, whatever. Yes, okay. This kind of looks like if the n si, then sj to the n. First off, is such a sentence, and let si and sj at the final recursion or whatever be some actual declarative sentence. I ate an apple, whatever, right? Is such a sentence grammatically correct? You don't think so?
Technically, yes.
Especially technically.
But
That's what we care about.
I mean,
Why not? I mean, but
if we're going like logically, yes, it has like it is grammatically correct since it's just like the if-then format.
yes.
If some clause, then SJ. The problem is that clause is another if statement, so it's basically like a nested if statement kind of, which just, once it gets long, it starts losing meaning to.
I claim it does not lose meaning by an inductive argument if you assume SI and SJ are themselves declarative sentences, and you assume S is a declarative sentence, which it is, if SI then SJ is declarative, then by kind of induction, any composition of a declarative sentence in there must also be declarative. So, although uncomfortable and actually confusing and easy to get lost, here's an example. If I go to the store, then I'll buy an apple, then I'll bring an umbrella home. So in the condition statement of the if is technically another declarative sentence, which is itself an if statement, okay? First part, is it grammatically correct? I would say yes. Is it confusing and is it hard to keep track of it? That's a more semantic notion, because it's like, if it's true, I have to do a little more. I don't even like the Python ternary stuff where you do the question mark, inline stuff. It's difficult to read. So complicated, sure. Grammatical, I think we should all say it is grammatical. Does anyone disagree after I said that this is grammatically correct? Okay. Now, this is just a single string though. Can it be explained by regular methods? First off, what does this look like? Like a language we've seen before, what do strings of this form kind of appear to be?
Was it context-free grammars or
A specific language that was produced by context-free grammar, yes.
A to the n, B to the n?
Yeah, this is kind of like A to the n, B to the n, which we know is context-free, but in the context of this, not regular, right? Now, that's the second thing. This is kind of, in fact, if we want to be precise, this is a homomorphism of a non-regular context-free language. And we know the context-free languages are closed in homomorphism, so you could say, well, that's A, that's B, let's say that's a C or something, and then you could say that's the homomorphism, right? But by analogy, it's good enough. This is not regular. Okay, good. Now, here's a question we have to ask, because we are working in the intuitive and not in the formal. Can a DFA, a regular device, still sufficiently explain this? Perhaps like we said before, let's say the recursion may be bounded up to depth 17. Does that really explain this? I mean, again, we still have the same inductive argument. We agree that if SI and SJ are declared, then so is S. But there is not necessarily a simple bound we may place on how many times we may take that recursion. So we come back to the same argument. If, let's say, there was a bound on the recursion, we could hard code those into a lookup table, and we're back at the similar argument, right? The second thing I'll say is, can this be explained by a regular, not just in the infiniteness, but perhaps a regular device that still agrees upon the infiniteness of grammatically correct sentences? What is the difference really between A to the n, B to the n, and A star, B star? Yeah, exactly. This language is in fact regular. Why? There's a simpler answer, but that's absolutely correct.
Because you can be represented by a DFA or NFA.
There's even a simpler answer. That's a regular expression, so obviously it's regular. So I gave you the regular expression, so yeah. To be more cognitive, this, as you said, you can decide this language without having to keep track of the number of A's, making sure that it's equivalent to the number of B's. You must do so for this one, and no DFA can sufficiently do that. We proved that by the pumping lemma. But here you just got to make sure that there's all the A's come before all the B's, and you can do that in a very local, sweeping scenario, right? You just check, am I seeing A's? Oh, I see a B, make sure I don't see any more A's. Very simple to do that DFA. Here, you got to count the A's, and then make sure that exactly the right number of B's come after. Not near the number of B's, but exactly the number of B's. The difference between these two is, in fact, one is a subset of the other, right? In fact, a strict subset. So, could such a thing be explained by something analogous to A star, B star? I claim that this is a grammatical subset of English, but I also claim that if star SI, then SJ star is ungrammatical. Do we agree with that claim? If the number of ifs does not correspond precisely and exactly to the number of thens, I claim it is ungrammatical. Now, do we agree with that? You don't agree with that. Why not?
Because if you're saying that the ifs equal the amount of thens, that's kind of like a meaning versus if,
Oh.
then, si, then I, if you were to continue talking about something else, or even the same thing.
I would say that the structure of the sentence having an equal amount of ifs, the number of ifs equaling the amount of thens, is a property of the sentence that I would say is syntactic. Now, if those ifs are causal in some sense, like the implicative flow, like, sounds good, that I think would be semantic. But I would disagree and say that the number of ifs equaling the number of thens is a semantic property. So maybe, because, and basically the way you can just tell is a property semantic or syntactic is like, can you determine it just by looking at the sentence without knowing its meaning? Just looking at the word order and the word frequency and things like this, right? So counting ifs and counting thens, I think, would be syntactic. Is there another reason you would disagree that this is grammatical? This could be grammatical still.
What do you mean by, so if it's semantically correct because it has the equal amount of ifs and thens?
Semantic could be many different things. It could be, is the sentence true? Does the sentence convey an idea? Like, for example, we said furiously by ideas being colorless has no quote-unquote semantic value because it doesn't actually convey an idea. So an idea conveyed by the sentence would be part of its semantics, necessarily.
But isn't it being grammatical different from it being semantically correct?
Correct. But I assert here only in the context of grammatical, that is a subset which is ungrammatical. That's my claim. Without saying anything about the semantics yet, just about grammar. And by the way, basically the whole point of that example is that semantics is too difficult to study. Let's study structure only, and let's kind of focus on that.
Gotcha.
Would you agree, back to the question though, would you agree that's grammatical or ungrammatical? Like, in the same way the sentence A, colorless green ideas think furiously, is grammatical. Would you agree that a sentence with a mismatched number of ifs is grammatical or not?
If that's the syntax where one equals the other, then no,
Okay.
it's ungrammatical.
Does anyone else agree or disagree? Does anyone else disagree that such a language is ungrammatical?
I have two arguments.
Yes.
The first is that, okay, if I say SI then SJ, that's still English.
Correct.
So so the then has to be bigger or equal to if. So, has a mismatch could produce a grammatical sentence.
You're saying if the number of thens exceeds the number of ifs?
Yes, but that's still,
Could you give me an example? I think I know what you're going to say, and I haven't answered, which is why I'm hoping you'll.
Yeah. What do I say then?
I see. So there is in English a notion of a hanging statement in some sense, like you could use if in a way that's not a fully formed if then. The same way a programming language has an if but does not require matching else. So you could say if I don't die,
Of course.
you could say if I buy an apple, then I go to the market, then I go home.
Exactly.
But the way someone who was too formal about that would say is that, like, if I go to the market, then I go home. If I go to the market, then I go home, then I buy an apple. If I go to the market, then I buy an apple, then I go home. This is the implicature, right? This is the part that's thing, and then this is an appended sentence, the
Yes.
concatenation.
But you have one more than the if, right? So, right?
Yes, so then the defense would be, and I'm not saying I fully agree or anything, the defense would be this is the part that's matched, if must match those thens, and then this is an unrelated appendage,
Oh, I see.
a concatenation.
It still follows the same form.
Sure. But I will also tell you that A to the N, B to the M, such that N is less than or equal to M, is
Of course.
also, by a pumping lemma argument, still non-regular.
Of course. But it is a mismatch at least.
Yes.
Right.
Yes.
which your question was about mismatch.
Yes.
And second, because let's go back to the innate definition of grammar,
Mhm.
right? I mean, if you say a mismatched sentence with like 100 ifs, right? Then I don't think I can tell how much you said, right?
Yeah, no,
And
that's another good point. If you do 100 ifs
Yeah.
and you only do 99 thens, you may not
Yeah,
catch
and
it.
I will be tricked into thinking that's grammatically correct, even though it's mismatched.
I suppose in context, then, here's another argument against it. A grammarian may say this. Utterance and writing are two different scenarios. In utterance, you must compute the sentence during listening, and then in writing, perhaps you can go back and trace. Something like this. And assuming that your brain also has good enough recursion, hearing if, the same way the program's control flow would chain down, so would you. And then you would only work outside in, eventually making sure the ifs match the thens. In theory, like in a fast reading scenario, we don't do this though. So this is up to, any final questions on this before we take a quick break? Oh, the most important theorem, I forgot. This is the first theorem of the class in some sense. What is the point of this? Here's a corollary. We do English. This is non-regular English. The brains, the pipes and wires in the brain, therefore, cannot be, at least the part responsible for language, cannot be wired up like that of a DFA. It must be something stronger than a DFA. Not even an NFA, something explicitly non-regular. So we can say something about a theory of the mind without surgery. We can say something about the way the brain is wired up simply by looking at inputs and outputs. And that is one of the reasons linguistics, some people consider it to be a theory of the mind. That's a jump in corollary, and understand that when we say something about a formal object and try and correspond that back to the intuitive, there are tons of conditions about how you apply such a theory, right? But does anyone disagree with that statement? The part of the brain responsible for language cannot be wired up like a DFA. It doesn't say what it could be wired up like. It doesn't say anything about that. But we at least know it's not a DFA. Disagreements, questions on that one? Okay. One more final parting thought about why linguistics is a theory of the mind. It's as if you only look at outputs to try and say something about the internal wiring, which is not exactly like the best way to do that computationally or neurally. I don't know, but it works a little bit. It's as if you were like looking at an artist's paint strokes and trying to go backwards and say what the paintbrushes must have looked like. Like, it would be easier just to look at the paintbrush and say what the output of the brush would look like. But instead you look at the painting and you try to see, okay, well the strokes have this kind of fuzziness to it, so maybe the brush looked like this. And it's very conjecture based and you're trying to work backwards in some sense. But again, ideas represented by language, you look at the language, limits ideas. Examples are here. So, let's take a quick break.